Hello, this is Sujit. Welcome to Physics 2020. So let me continue my discussion in the topic of in the chapter that is motion in a plane. So I think this is the fourth section in this chapter that is motion in a plane. So in the first three sections we have discussed in the first section we have discussed the introduction about vectors. In the second section we have discussed the triangle and the concept of triangle and parallelogram law of vectors. And the third section we have discussed the numericals using triangle law of vectors and parallelogram law of vectors. So in this section we are going to discuss the resolution of vectors. It is another very important topic in physics. Okay, that is resolution of vector. Suppose if a vector is given, how that vector can be resolved into its components in 2 dimension or in 3 dimension. Okay, 2 dimension or 3 dimension, how that vector can be resolved into its components. In 2 dimension, suppose a vector is given, how we can resolve that vector into its horizontal component and vertical component. Okay, vertical component. In 3 dimension, what are the components of that vector along the x-axis, y-axis and z-axis? Okay, so these are the things we are going to discuss in this section. So if a vector is given, how to find out the components of that vector, what is the significance of these components of vector in physics? Okay, physics, these are the things we are going to discuss. Also, that is how to find the magnitude of the vector. Okay, so these are the things we are going to discuss in this section. Okay, fine. So first of all, we start with that is unit vector. Okay, unit vector. Unit vector. What is a unit vector? So unit vector is a vector which has the magnitude of unity. Okay, magnitude of unity which is drawn in the direction of a particular vector. Okay, particular vector. So the purpose of unit vector is to give the direction or indicate the direction of a particular vector. So that vector, that is also vector that has the unit magnitude. Okay, unit magnitude which is drawn in the direction of a certain vector. So what is the purpose of this unit vector is it is used to represent the direction of a certain vector. Okay, so a vector, suppose a vector. So a vector is equal to, we can write that is magnitude into direction. Magnitude into direction. Okay, so a vector means that is it has a magnitude and it has a direction. Okay, so that is magnitude is that is modulus of a vector. Okay, modulus of a vector, it gives the magnitude. So into direction means a cap. Okay, a cap. So a cap is the unit vector. A cap is the unit vector which acts in the direction of this vector A. Okay, vector A. So from this what is unit vector? That is a vector is equal to, so a cap is equal to a vector divided by modulus of a vector. Okay, modulus of a vector. So this is the formula. This is the formula used to find the unit vector. Okay, unit vector. So a cap is equal to a vector divided by modulus of a vector. So understand that a vector is nothing but magnitude into direction. So magnitude means modulus of a vector. That is mod a gives the magnitude of that vector into a cap. A cap is the unit vector. So which is of unit magnitude which is acting in the direction of this vector. Okay. So from this a cap, that is a unit vector of this vector, how we can find the unit vector of this vector? If a vector is given, okay, if a vector is given, how to find the unit vector of that particular vector? So a cap is equal to a vector divided by modulus of a vector. Using this formula we can find the unit vector. Okay. Next we are going to see that is orthogonal triad of unit vectors. Orthogonal triad of unit vectors. orthogonal trade-off unit vectors. So in a right-handed Cartesian coordinate system, okay, right-handed Cartesian coordinate system. So what is a right-handed Cartesian coordinate system? So three axes, mutually perpendicular axes. Okay. So this is the x-axis, this is the y-axis, and this is the z-axis. So this is the origin. Okay, so in a right-handed Cartesian coordinate system, so three unit vectors, that is I cap, j cap and k cap. Okay, k cap. So these are the three unit vectors, that is mod I is equal to mod j is equal to mod k. Okay, mod k is equal to 1. So these three are the unit vectors. These three unit vectors are used to represent the direction of this x, y and z axis. Okay, so this is unit vector, that is I vector, I cap. So I is the unit vector which is used to represent the direction of the x axis. Okay, so j cap. Okay, so j is the unit vector which is used to represent the direction of the y axis, and k cap, k is the unit vector which is used to represent the direction of the z axis. Okay, z axis. So these three are unit vectors which is used to represent the direction of x, y and z axis respectively. Okay, respectively. These three vectors, unit vectors I vector, j vector and k vector, are collectively known as orthogonal trade-off unit vectors. So orthogonal trade-off unit vectors is nothing but these three are unit vectors. I vector, j vector and k vector are unit vectors of magnitude 1 which is used to represent the direction of x axis, y axis and z axis respectively in the right-handed Cartesian coordinate system. Okay, so this is called orthogonal trade-off unit vectors. Okay, rectangular, rectangular components of vector. If a vector is resolved into two mutually perpendicular directions, okay, if a given vector is resolved into two mutually perpendicular directions, so the components so obtained are called, okay, that is rectangular components of a vector. Okay, so if a vector is given, for example, if a vector is given, okay, that is OP, okay, OP, that is a vector. So if this vector is resolved along two mutually perpendicular directions, okay, perpendicular directions, so the component of this vector along the horizontal direction and the component of this vector along the vertical directions are called, that is rectangular components of vector. Okay, if a vector is given, if a given vector are resolved along two mutually perpendicular directions, okay, mutually perpendicular directions, then it is called, that is rectangular component. So we will get two components, that is one component along this direction, one component along this direction. Okay, these two components are called, that is rectangular components of the vectors. Okay, so the next we are going to see the rectangular components of vector in two dimensions. Rectangular components of vector components of vector in two dimension or vector in a plane. Okay, in a plane. Okay. So this is x-axis and this is y-axis. Okay, y-axis. So this is the origin. So we have a vector starting from this origin. Okay, starting from this origin. So OP vector. So we call it that vector as A vector. Okay, A vector. So in two dimension, that is in a plane. Plane means two dimension. So consider the x-axis and y-axis. And we have a vector starting from the origin. Okay, starting from the origin. So that is OP. So we call it that vector as A vector. Okay, A vector. So the projection of this vector, in the x-axis, that is PM. Okay, PM. And the projection of this vector in the y-axis, that is N. Okay, N. So these two OM vector and ON vector along the x-axis and ON vector along the y-axis are called the two components of this vector. Okay, two components of this vector. So OM vector along the x-axis is called the horizontal component of this vector, horizontal component. So I am taking that is AX vector. Okay, AX vector. And the vertical component along the y-axis is called that is AY vector. Okay, AY vector. Right? So these vectors, these components, that is the vector component along the x-axis, that is OM vector or AX vector, and this is called the horizontal component, and that is AY is called the vertical component of this vector. Suppose this vector makes an angle theta with the x-axis. Okay, with the x-axis. Okay. So according to parallelogram law of vectors, we can write that is OP vector is equal to, that is OM vector plus ON vector. Okay, OM vector. So OP vector is equal to parallelogram law of vectors. We have already studied. So OP vector is equal to OM vector plus ON vector. Am I right? So what is OP vector? That is A vector. So A vector is equal to AX vector plus AY vector. Okay, AY vector. Okay, AY vector. Okay. So otherwise we can write, suppose I vector, I cap and j cap are the unit vectors along the x-axis and y-axis respectively, means we can also write that is A vector is equal to AX I cap plus AY j cap. Okay. A vector is equal to AX I cap plus AY j cap. So the vector makes an angle theta with the x-axis. So from this, from triangle OPM, okay, OPM, from triangle OPM, cos theta is equal to adjacent side, that is OM divided by hypotenuse, that is OP. So cos theta is equal to ax divided by a. Okay, a. So from this the horizontal component ax equal to a cos theta. So this is the horizontal component of this vector, a vector. Ax equal to a cos theta. Okay, horizontal component. So similarly, sin theta is equal to opposite side, that is Pm by hypotenuse, that is OP. So Pm, that is Ay divided by, that is A. So Ay is equal to A sin theta. So this is the vertical component of the vector. Okay, vertical component of the vector. So the magnitude of the horizontal component and vertical component, this is very important. That is ax equal to a cos theta and ay is equal to a sin theta. If a vector is given and the vector makes an angle theta with the x-axis means, so the what is the magnitude of the horizontal component, that is ax equal to a cos theta and ay is equal to a sin theta. Okay, so ax square plus ay square is equal to a square cos square theta plus a square sin square theta. Okay, sin square theta. So that's equal to, take a square commonly outside, that is cos square theta plus sin square theta. So that's equal to a square. So a square is equal to ax square plus ay square. Okay, ay square. So a is equal to square root of ax square plus ay square. That is very, very important formula. That is the magnitude of this vector. Okay, so this is our vector, a vector. So the magnitude of this vector a is equal to square root of the square root of the square of that what, the horizontal component x component and y component. So if a vector is given, these are the things you have to know. So this is a horizontal component, this is the vertical component, and what is the magnitude of this vector? Magnitude of the vector can be found, a is equal to square root of ax square plus ay square. Okay. So this one. So now the unit vector formula, that is a cap is equal to a vector divided by mod of a vector. So that's equal to unit vector is equal to a vector divided by, what is mod of a vector? That is the magnitude. Okay, so that is square root of ax square plus ay square. Okay, y square. So this gives the unit vector of a given vector. So this formula also you have to keep in mind. So this you keep in mind, this also, this and this one. Okay. So the next one is rectangular components of a position vector. So rectangular components of position vector. P of x comma y is a point. Okay, so this is the x-axis and this is the y-axis. Okay, y-axis. So OP Vector is the position vector. Okay, position vector. So let PM be the perpendicular in the x-axis and Pn is the perpendicular or projection of this point, this position vector. So the position vector r vector, okay, r vector, and the position vector takes an angle theta with the x-axis. Okay. So this projection of this position vector in the x-axis is, that is OM vector, that is x I cap, and the projection of this in the this vector position vector in the y-axis is, that is y j cap. So that is ON vector. So we can write OP vector is equal to OM vector plus ON vector. Okay. So OP vector, that is r vector is equal to x I cap plus y j cap. Okay, y j cap. So considering the triangle, that is OPM, cos theta is equal to, I am writing here, that is cos theta is equal to PM by, that is OM by OP. Okay, OP. So that's equal to, what is OM? That is x divided by OP, that is R. Okay, R. So from this, x equal to R cos theta. So that is the horizontal component. Okay, horizontal component. Then sin theta is equal to opposite side, that is PM by hypotenuse, that is OP. So that's equal to, what is PM? That is y divided by OP, that is R. So y is equal to R sin theta. Y is equal to R sin theta. So this is the vertical component of the position vector. So x equal to R cos theta is the horizontal component, y is equal to R sin theta is the vertical component. Okay. So x square plus y square is equal to R square cos square theta plus sin square theta. Okay. So R square is equal to x square plus y square. R is equal to square root of x square plus y square. So this is the magnitude of the position vector. So R is equal to x square plus y square. So the vector R vector can be written as this form. You have to know, that is R vector is equal to x I cap plus y j cap. So the horizontal component x equal to R cos theta, you know, y is equal to R sin theta, and the magnitude of the vector R is equal to square root of x square plus y square. Okay. So rectangular components of a vector, components of a vector in 3 dimension. 3-dimensional. Okay. So consider a parallelepiped So from this, so this is our x-axis, so this is our y-axis, so this is the z-axis, y-axis. So from the origin, so the diagonal of this parallelepiped, our vector is acting along the diagonal of a parallelepiped. Okay. So from the origin, so this is P. So A vector. Okay, A vector. So the A vector makes the intercept at x, y and z axis. So let OM, okay, OQ be the intercept of the vector along the x-axis. That is the projection of this vector in the x-axis. R, that is OR along the z-axis, and OS, okay, OS along the y-axis. So the OQ vector I am taking, that is AX vector, OS vector, that is AY vector, and AZ vector. Okay, AZ vector. So the vector makes an angle alpha with the x-axis, beta with the y-axis, and gamma with the z-axis. Okay, z-axis. So from triangle law of vectors, OP vector is equal to OT vector plus TP vector. So I am considering this triangle, that is OTP. Okay, OTP. So according to triangle law of vectors, we can write that is OP vector is equal to OT vector. Okay, OT vector plus TP vector. So from parallelogram law of vectors. Okay, parallelogram law of vectors. So I am considering this parallelogram. Okay, that is ORTQ. Okay. So OT vector is equal to OQ vector plus OR vector. Okay, OR vector. So this is the resultant of this parallelogram. So OT vector, we can write OT vector is equal to OQ vector plus OR vector. So according to parallelogram law of vectors. So we have already discussed, that is a triangle law of vectors and parallelogram law of vectors. Okay. So therefore OP vector is equal to, so instead of this OT vector we can write that is OQ vector OQ vector plus OR vector plus then TP vector. Okay, TP vector. So, but TP vector is nothing but TP vector, that is a y-axis length. Okay, so TP vector is equal to, we can write that is OS vector. Okay, OS vector. So therefore, OP vector is equal to OQ vector plus OR vector plus OS vector. Okay, OS vector. What is OP vector? That is our vector, that is A vector. A vector is equal to, what is OQ? That is AX. AX vector, that is the X component, plus what is OS? That is the Y component, that is AY vector, plus what is OR? That is the Z component, that is AZ vector. Okay, AZ vector. Suppose if I vector, I cap, j cap and k cap are the unit vectors along the x, y and z axis. Okay, z axis. So we can write A vector is equal to AX, that is the magnitude, I cap plus AY j cap plus AZ k cap. So this is our vector. So this form you should know, that is our vector, our given vector, that is A vector, can be resolved into the three components, X component, Y component and Z component. Okay, Z component. So by considering the triangle, that is this right angle triangle, so the vector makes an angle alpha, beta and gamma with the three axes. So these all are the three right angle triangles. Okay, right angle triangles. So that is OP. It is a right angle triangle. Okay, right angle triangle. So we can write, so cos alpha is equal to adjacent side, that is AX divided by hypotenuse, that is our A vector. Okay, A vector. So from this, AX equal to AX by A, that is magnitude. Okay, AX equal to A cos alpha. Okay, similarly, cos beta is equal to AY by, that is A. So AY is equal to A cos beta. This is the component along the y axis. So cos gamma is equal to AZ divided by A. So AZ is equal to A cos gamma. So this is the component along the Z axis. Okay, Z axis. Okay. So the vector can be resolved into three components, that is the component along the x axis, component along the y axis and the component along z axis, that you should know. So what if the x, y and z component, ax equal to a cos alpha, y is equal to a cos beta and az is equal to a cos gamma are the three components of vectors. Okay. So A vector is equal to Ax I cap plus Ay j cap plus Az k cap. So what is the x component? Ax equal to A cos alpha, Ay is equal to A cos beta and A Z is equal to A cos gamma. Okay, A cos gamma. Okay, now from this triangle, so this is a right angle triangle, that is OPT, right angle triangle. So OP square, Pythagoras theorem, OP square is equal to OT square plus TP square. Okay, TP square. So again this OT square is equal to, this is a right angle triangle, that is OT square OQ OT. So this is a right angle triangle. So that's equal to, what is OT square? OT square is equal to OQ square plus QT square plus TP square. Okay, TP square. So what is OQ square? OQ square. So OQ square is equal to nothing but that is AX square plus, what is QT square or TP square? TP square, what is TP square? That is AY square plus, what is QT square? That is AZ square. Okay, Z square. That is, what is OP square? That is A square. A square. Am I right? So from this, A is equal to square root of AX square plus AY square plus AZ square. Very, very important. So this is the magnitude of the vector. So magnitude of the vector. Okay, so vector in 3 dimension. Okay, 3 dimension. So how we can find the magnitude of the vector means A is equal to square root of AX square plus AY square plus AZ square. So if a vector is given in a 3 dimension, okay, 3 dimension means, so the vector, this form you should know, the vector can be written as a X component, Y component and Z component. A vector can be resolved into 3 components, that is along the X axis, Y axis and Z axis. So the component form you should know, that A is equal to AX. AX is the magnitude of the X component, I is the unit vector along the X axis. AY is the magnitude of the vector in the Y axis, and J cap is the unit vector along the Y axis. So similarly, AZ is the magnitude of the vector along the Z axis, and K cap is the unit vector along the Z axis. Okay? So AX, so the component X, Y and Z components can be found. That is because the vector makes an angle alpha, beta and gamma with the 3 axes. So by that angle, the component along X axis is equal to A cos alpha, AY is equal to A cos beta, AZ is equal to A cos gamma. Okay, and the magnitude of this vector can be found with the formula, that is A is equal to root of AX square plus AY square plus AZ square. Suppose a position vector in 3 dimension, okay, 3 dimension can be written in the form, that is R vector is a position vector in 3 dimensions. So we can write R is equal to X I cap plus Y j cap plus Z k cap. So a position vector in 3 dimension. So in the component form we can write R vector is equal to Xi vector plus Yj vector plus Zk vector. Okay. So what is the magnitude of this position vector? That is modulus of R vector is equal to square root of X square plus Y square plus Z square. Okay, Z square. So that is very, very important. So the modulus of the magnitude of the position vector. Okay, so this is the rectangular components of a vector in 3 dimension. So with this I wind up this session. So the resolution of vectors and unit vectors and resolution of vectors. So in the next section we will discuss the problems in the concept of, that is unit vector and resolution of vectors. Okay, stay tuned. Bye.